When you picture General Motors, you naturally picture massive Detroit assembly lines.
Oh, yeah. Big factories.
Right, like
Yeah.
heavy-duty pickup trucks and this whole corporate identity built entirely on motion, like internal combustion and raw horsepower.
Definitely. A century of moving fast.
Exactly. But in today's analysis, we are looking at this massive contradiction.
Right.
GM's next billion-dollar business might have absolutely nothing to do with moving people around.
Wait, really? Nothing at all?
Nothing. It might be entirely about sitting perfectly still.
Oh, wow.
Yeah, acting as a stationary power plant. So, welcome to today's analysis. Our mission today is to explore how a traditional automaker is quietly trying to pivot into, well, a distributed energy company.
Which is just a complete shift in their operational DNA, I mean, if you think about it.
Yeah.
And this pivot is being forced by a collision of two major, seemingly unrelated market pressures.
Okay, what's the first one?
First, you have electric vehicle adoption, which is currently plateauing. It's moving significantly slower than the industry's highly optimistic early forecasts.
Right, they expected everyone to have one by now.
Exactly. And second, you have the explosion of the artificial intelligence sector.
Oh man, the power demand there.
Right. It's creating an unprecedented structural power shortage across the entire electrical grid.
The scale of that AI power shortage is what really stands out here, I think. We all know data centers use electricity, but the shift from traditional cloud computing to generative AI, it requires a completely different magnitude of infrastructure.
It really does. Because traditional internet servers, they're mostly just retrieving data. You search for a website, it sends you the data, done.
Simple enough.
But AI requires continuous, intensive computation. When you run tens of thousands of advanced GPUs simultaneously to, train an AI model, they generate massive amounts of heat.
So it's not just the chips themselves drawing power.
Not at all. You aren't just powering the silicon chips. You're powering industrial liquid cooling loops and heavy-duty HVAC systems just to keep the servers from literally melting.
Literally melting.
Yeah.
Yeah.
Add in the absolute requirement for 99.999% uptime, and a single new AI data center can demand the exact same electrical capacity as a mid-sized city.
That is insane. And the physical grid just wasn't designed for mid-sized cities to pop up overnight.
No, it really wasn't.
Think of our current electrical grid, like the interstate highway network. It's already operating at maximum capacity during rush hour.
Bumper to bumper.
Right. So if you suddenly build a cluster of megacities right next to it, you can't just drop a new lane and pave it the next day.
High-voltage transmission lines take a decade to permit and build.
Exactly. So if we can't generate and transmit new power fast enough for these data centers, the only solution is time-shifting the energy we already have.
Yes, that is the core mechanism of energy arbitrage, and it is entirely reliant on battery storage.
Because the grid doesn't just have a flat supply and demand,
Yeah.
right?
Right, the grid does not have a flat, constant curve. In the middle of the night, baseline power plants and wind farms are generating electricity, but human demand is incredibly low.
Everyone is asleep.
Exactly. So that power is cheap, sometimes even negatively priced. But during a hot afternoon, demand spikes and power becomes exponentially more expensive. Batteries allow you to buy that off-peak power, store it, and discharge it to the data center when the grid is, redlining.
Which brings us directly back to General Motors. GM is currently manufacturing millions of high-capacity batteries for their vehicles.
Huge amounts of them.
But statistically, an average car sits parked in a driveway or a parking lot for about 95% of its life.
Just doing nothing.
Just doing nothing. So from a purely economic standpoint, a parked car functioning as a node in a distributed energy network might actually generate more recurring revenue than a moving car.
It forces automakers to look at their own products completely differently. And this strategy doesn't just apply to new cars sitting in driveways.
What do you mean?
Well, the more fascinating play here is what happens to the batteries after the vehicle itself reaches the end of its road life.
Okay.
There is this concept in battery lifecycle management that is essentially the transition from professional athlete to coach.
Okay, wait, athlete to coach. I love that. Let's break down the physical mechanism there, because an EV battery doesn't just die one day like a light bulb burning out.
Exactly. It comes down to cycle aging versus calendar aging. Every time you charge and discharge a lithium-ion battery, you are physically forcing lithium ions back and forth through an internal separator.
So there's physical wear and tear?
Yes. Over thousands of cycles, this creates microstresses and chemical degradation. After 10 years in an EV, that battery might lose 20% of its total capacity.
Which is annoying for driving range.
Very. But more importantly, its internal resistance goes up. That means it can't deliver massive, instantaneous surges of power anymore. It loses its ability to sprint from 0 to 60.
So the metaphorical knees are shot, they can't run the fast break, but they still have the basketball IQ.
Precisely. Even if it can't sprint, it still holds a massive reservoir of energy. So GM takes that degraded battery pack, pulls it out of the vehicle chassis, and drops it into a stationary shipping container next to an AI data center.
Because the data center doesn't need to go 0 to 60.
Right. It doesn't need rapid acceleration.
Right.
It just needs a slow, steady, predictable drip of reliable power.
So the battery transitions from a high-performance athlete on the road to a reliable stationary coach on the grid.
Exactly.
And GM is actively building out the infrastructure to do exactly this. They have a major partnership with Redwood Materials to handle this second life cycle.
Which is huge.
Yeah, taking what used to be the single biggest sunk cost of building an electric car and attempting to turn it into a multi-decade revenue asset.
It's a brilliant pivot. On paper.
Right, on paper. Because here is where we have to look at the logistical reality of the vehicle-to-grid, or V2G, pitch.
The messy part.
Because if GM tells you they want to pull power from your expensive new EV in your garage to keep the local data center running, your first thought is probably going to be about your own battery's lifespan.
Oh, 100%.
Like, why would I volunteer my car for extra cycle aging just to help the utility company balance their load?
And that is the exact bottleneck of this entire business model. The theoretical capability is brilliant, but the execution is hitting a massive wall of what industry insiders call grid friction.
Grid friction. Man, it sounds like a bureaucratic nightmare. What does that actually look like on the ground?
It is a nightmare. Grid friction is the combination of mechanical, regulatory, and financial sludge slowing down the energy transition.
Sludge is a good word for it.
Yeah. Mechanically, to do vehicle-to-grid charging, your house needs a bidirectional inverter.
And those aren't cheap.
No. That hardware alone, plus the specialized electrician required to install it, can cost a homeowner several $1,000s up front.
Just to get started.
Just to get started. Then you have the regulatory side interconnection queues.
Right, because you can't just plug a massive bidirectional power source into the grid without the regional utility's permission.
You absolutely cannot. You have to undergo grid impact studies to ensure your system isn't going to blow out the neighborhood transformer.
Which would make the neighbors very unhappy.
Very. Right now, across the country, there are thousands of energy storage projects literally waiting in line for years just to get a permit from regional utility monopolies to connect to the grid.
Years.
Years. The physical transformers themselves are back-ordered, and there is no standardized software protocol between different utility territories to coordinate millions of individual cars charging and discharging simultaneously.
Wow, and add customer warranties to that friction.
Oh, the warranties.
Right. If I degrade my car's driving range so the utility can avoid a summer blackout, GM has to have ironclad, totally transparent warranty policies about who pays to replace those degraded battery cells.
Yeah, it's a massive logistical and legal puzzle.
But if they figure it out...
It is deeply complex. But if an automaker can actually smooth out that friction, the entire strategic battlefield of the industry flips upside down.
How so?
Well, for 100 years, the auto industry was strictly a road business. You built a machine, sold it, and the transaction was largely over.
See you in 10 years when you need a new one.
Exactly.
Yeah.
Today, the physical electric vehicle is just the entry point. The customer's home ecosystem, their charger, their smart panel, their solar roof, is the next node.
Okay.
And the electrical grid itself is the ultimate market.
So if the grid is the new market, GM isn't just competing with Ford and Toyota anymore.
Not at all.
They are stepping into a radically different arena. Tesla has been building out their megapack, utility-scale storage, and Powerwall home businesses for a decade.
They're way ahead on that front.
And you have dedicated energy storage titans like Fluence, and you have the massive Chinese battery conglomerates like CATL and BYD who operate with staggering manufacturing scale and government backing.
Which forces a very critical look at GM's true motives here, I think.
Yeah, we have to weigh whether this is a visionary, proactive pivot into the energy future or a reactive scramble for a secondary business model.
Because traditional EV profit margins are proving to be brutally difficult to maintain.
Right. Let's run through the bear case first.
Okay.
The skeptics would look at the thousands of dollars required for bidirectional home hardware, the notoriously slow-moving utility monopolies, and the simple fact that AI hyperscalers might demand brand new purpose-built battery farms.
For maximum reliability.
Exactly, rather than dealing with the varied, unpredictable degradation of Second Life car batteries.
Yeah, the bearish view is that the synchronization required between automakers, local utilities, and everyday consumers is just too complex to scale profitably in the near term.
But there is a bullish case.
There is. The bullish case for GM relies on their absolute mastery of mass production. They know how to bend metal and build complex hardware at a volume of millions of units per year.
They've been doing it for a century.
Right. They have deep-pocketed battery joint ventures already operational. And frankly, the stark necessity to diversify their revenue beyond razor-thin automotive margins gives them a massive financial incentive to push through the grid friction.
They kind of have to make it work.
They do.
Which means GM's execution on battery storage might actually be a better indicator of their long-term survival than their quarterly car sales.
I completely agree. The vehicle sales just tell us who is buying cars today.
Right.
The energy storage execution tells us if they have a seat at the table in tomorrow's distributed energy economy.
Because the fundamental economics of transportation are shifting.
Yes.
Yeah.
In the 20th century, the car was the final product. In the 21st century energy economy, the car is just the platform.
The platform for what?
The real product is the recurring revenue from energy arbitrage, grid stabilization services, and the software ecosystem managing it all. Automakers are waking up to the reality that the battery has outgrown the vehicle.
Think about what this means for your own daily life. This isn't just a corporate strategy shift happening in a boardroom somewhere.
No, it affects everyone.
It's a shift that will directly impact your future electricity rates, the stability of your local power grid during extreme weather, and the physical infrastructure required to run the AI tools that are becoming embedded in everything we do.
The physical infrastructure of the internet is officially merging with the physical infrastructure of transportation.
Which is wild to think about.
They are becoming one continuous system.
Which leaves you with a fascinating dynamic to consider the next time you plug a device into the wall. If the software integration becomes seamless and the hardware costs drop, would you be willing to lease out your car's battery to the grid while you sleep to zero out your monthly electricity bill?
Or will range anxiety make you fiercely protect every single kilowatt hour for your morning commute?
Exactly. Because the next titan that keeps the lights on in your city might not be a traditional utility or a fossil fuel company. It might just be an automaker managing 1 million batteries parked silently in driveways across the country.